There are two types of salts. The first type is neutral salts. A neutral salt is produced when the hydrogen of an acid is completely replaced by a metal. The second type is an acidic salt. An acidic salt is produced when the hydrogen of an acid is partially replaced by a metal. This can happen only in di and triprotic acids or di and tribasic acids. For example, sodium plus sulfuric acid SO4 plus H2. So this is an acidic salt. Now, solubility of salts. All nitrate salts are soluble. Most chlorides are soluble, except all chlorides are soluble except LSM. L stands for lead chloride, S stands for silver chloride, and M stands for mercury chloride. All sulfates are soluble except BCl. B stands for barium sulfate, C stands for calcium sulfate, and L stands for lead sulfate. Now, for carbonates, all carbonates are insoluble except SPA. S is sodium, P is potassium carbonate, sodium carbonate, potassium carbonate, and ammonium carbonate, NH4 2CO3. Now, in general, for all halides, all silver and lead halides are insoluble. For example, silver chloride, lead chloride, silver iodide, lead iodide, silver bromide, all silver and lead halides are insoluble. For silver halides, silver chloride is white, silver bromide is creamy in color, and silver iodide is yellow. These are all precipitates because all silver halides are insoluble, so these are solid. Now we're starting the preparation of salts. For soluble salts, if for example we have a salt sodium nitrate, this is soluble, so it's aqueous. Now the first part of this salt will always be positive, and this will come from an alkali or a base, while the rest of it will be negative and will come from an acid. Over here, the base would be NaOH and the acid would be nitric acid. Now, to prepare salts, there are three methods. If we have to prepare a soluble salt and both the reactants are soluble, then we use titration. In titration, the reactants are an acid and an alkali, and both are dilute. A burette is filled fully with 50 centimeter cube of the alkali. If we're preparing NaNO3, we'll fill the burette with NaOH 50 centimeter cube. Then, using a pipette, we transfer 25 centimeter cube of nitric acid into the titration flask, also called a conical flask. In the titration flask, an indicator is added, for example, methyl orange. Now, if methyl orange is added, the color of the solution changes from colorless to red, because this is an acid. Now, NaOH from the burette is allowed to run into the titration flask until the color of the solution changes from red to yellow. The color changes because the moment all of the nitric acid is neutralized by sodium hydroxide, the solution becomes alkaline and the color changes to yellow, as methyl orange is yellow in an alkali. So once we've got the amount of alkali used to neutralize the 25 centimeter cube of acid, we repeat the titration with the known volume of the alkali without the indicator. This is how the solution of NaNO3 can be produced, a pure solution of NaNO3. Now we can be asked to get a pure sample or a pure crystal. Now, for pure sample, the solution of NaNO3 will be heated on a Bunsen burner till dryness. This will give us a powdered form of NaNO3. For pure crystals, NaNO3, the solution of sodium nitrate, is heated on a water bath until first crystal is seen. Then it is left to cool for crystal growing. Once the crystals are formed, they are filtered and washed with distilled water for purity. So that is titration. The second method for preparation of salts is filtration. Filtration is used to produce a soluble salt if the base is insoluble or if we're using an insoluble metal or metal carbonate. So, for example, if we have to produce crystals of copper sulfate, there will be three methods of producing copper sulfate. First, we can react copper oxide with sulfuric acid. We can react copper with sulfuric acid, or we can react copper carbonate with sulfuric acid. All will produce copper sulfate. However, the safest method is using copper oxide with sulfuric acid. And we'll use copper oxide instead of copper hydroxide because copper oxide is a solid and it is completely insoluble, so it is easy to separate from the mixture. Now, producing copper sulfate by filtration using copper oxide and sulfuric acid. So we take dilute sulfuric acid in a beaker and we add copper oxide in excess in that beaker. Now copper oxide will react with all of the sulfuric acid to produce copper sulfate and water, and the remaining copper oxide will remain in solid form in the mixture. The remaining copper oxide is filtered off. The solution that remains, that is copper sulfate and water, is heated on water bath till first crystal is seen. Then it is left to cool for crystal growing. Then the crystals are filtered and washed with distilled water and dried between the fold of filter paper. This is filtration. The third method for a preparation of salts is precipitation. This is used to prepare salts that are insoluble in water, but when both the reactants are soluble. So for example, if you have to prepare silver iodide, as all silver halides are insoluble, silver iodide is solid, we'll use two soluble reactants. So soluble for silver would be silver nitrate, and for iodide we'll have sodium iodide. Equal quantities of both the reactants are taken in a beaker and stirred. The reaction of these two will produce silver iodide solid and sodium nitrate aqueous. Now this silver iodide is a yellow precipitate. It is filtered out from the solution and is washed with distilled water and then dried in an oven. Now the ionic equation for this reaction, for a precipitation reaction, in this ionic equation we'll use the ions that form the precipitate. So those ions are Ag and I. So we'll have Ag plus positive aqueous plus iodide aqueous producing AgI solid. This is the ionic equation.